Okay, two cars start moving at the same time from the same point. One car goes straight north at 40 miles per hour and the other goes straight east at 30 miles per hour. After 2 hours, they have gone 80 and 60 miles respectively. How fast is the distance between them changing at this time? Okay, so first we will draw a diagram of the picture we have and then fill in any variables. We have both cars starting from the same point here. One is going east at 30 miles per hour. So we're going to write that in. 30 miles per hour. And we have one going north at 40 miles per hour. After 2 hours, they have gone 80 and 60 miles. So after 2 hours, they're right here and right here. And this distance from their starting point, it says this is 60 and this is 80. How fast is the distance between them changing at this time? So we're going to look for x here. We're going to call this y. We're going to call this z. We need to find the derivative of x. So first we need to figure out what x is. And we have x equals the square root of y squared plus z squared. And we're going to plug in both of our variables. So we have 60 squared plus 80 squared. So we have x equal to 60 squared is just 6 times 6 and add 2 zeros. So we have 360 plus 80 squared is just 8 times 8, add 2 zeros. 640, taking the square root of that, and we have x equal to 100. Okay, so we know the distance between the cars after 2 hours, but we don't know the rate that it's changing at 2 hours. So to find rate, we need to take derivative. We're going to take derivative of the Pythagorean theorem. So we have x squared equals y squared plus z squared. For taking derivative, we're going to do it implicitly with respect to time. And all that means is when you're taking the derivative, take it like normal, but then you're going to add in dx over dt, and this variable will be whatever you're taking the derivative of. So for instance, for x it'll be dx over dt, for y it'll be dy over dt, etc. The reason we're doing this is just because we're taking the derivative with respect to time instead of one of these variables. So dx, or 2x dx over dt equals 2y dy over dt plus 2z dz over dt. Okay, in the problem, it tells us that the car going east is going at 30 miles per hour. Miles per hour, distance over time, that's rate of change, that's a derivative. So for y, 30 miles per hour is our dy dt. And then it says going straight north at 40 miles per hour, miles per hour, distance over time, that's another derivative. So our dz dt is going to be 40. Our z, we calculated that to 80, it gave us that in the problem. Our y, they gave it to us as 60. So we're going to plug those in, and then also by Pythagorean theorem we figured out what x equals. So our only variable left now is going to be dx over dt. So we're going to have to get that on its side by itself. But first, we're just going to plug in everything. So we have 2 times 100 dx over dt equals 2. Our y value is 60, and our dy over dt is 30, plus 2, our z value we have is 80 up there, and our dz over dt we have as 40. So now it's just going to be some algebra. We have 200 here, we need to divide. We want dx by itself, so we're going to divide both sides by 200 and then just simplify all of this. So we have dx over dt is equal to 2 times 60 times 30 plus 2 times 80 times 40, and this is all going to be over 200. So then this is going to be 120 times 30, and that's going to be 6,400. And then 3,600. And this is all over 200. And adding these up, we get 50 miles per hour. The reason we're doing miles per hour is because we were looking at the derivative, and derivative is rate of change, and everything we've done is in miles per hour. So that's going to be our answer for dx over dt.